Today we are going to cover what is known as decision trees and decision making with and without experimentation. In the previous week we have seen the decision analysis, the various aspects of decision analysis, particularly what is decision analysis, the specific idea of payoff matrices, the value of information, and thereafter we have also seen the probability concepts and particularly the Bayesian analysis. So, how all of these combine together and we can actually analyze our decision making situation, particularly with and without experimentation, that these are going to be covered will be covered in the subsequent classes. Now, the first topic that we are going to have is what is known as the decision tree. Decision tree represents decisions and outcomes in a sequential or a chronological manner. Now, as you can see in that picture, there are certain nodes that will be available on a decision tree. The square node that we can call what is known as the decision node. The decision node is from which one of the several alternatives may be selected. So, as you know, any decision problem, there are two things. One are the set of alternatives amongst which we actually make a decision, and the second is the states of nature, and these states of nature sometimes also called as chance nodes, out of which one state of nature will occur. But why they are states of nature? Because on these we do not have any control. The decision alternative are within the decision maker's choice, but the states of nature are not within the choice of the decision maker. Then the arc or the branch represents possible decisions or states of nature. So, that is how the structure will be, and let us see a particular problem. This is a problem that we have dealt with previously. Suppose there are two states of nature, one is a favorable market, the other is the unfavorable market, and the payoffs are given, and there are basically three alternatives. We can construct a large plant or we can construct a small plant. If we construct a large plant, the payoffs will be 200,000 or minus 180,000, depending on whether the market is favorable or unfavorable. On the other hand, if we construct a small plant, we can get what is known as either 100,000 or minus 20,000 as payoff, depending on whether it is favorable or unfavorable market. And there is a third alternative also. If you do nothing, then we are not going to get any payoff, whether it is favorable or unfavorable market. Now, with this, and there are some probabilities, there are 0.5 each of favorable market and unfavorable market. Please remember, these probabilities are a priori or prior probabilities. What do they mean? That if we do not conduct any experiment, then before that experiment, these are the probabilities of the favorable market or the unfavorable market. Now, suppose we have to construct it to this payoff matrix to a decision problem, then how do we go about it? What we need to do? We need to first of all make a decision point. So, this is our decision point. So, at this decision point, basically we have three arrows will be emanating from here. Maybe we can put it like this. These are the three arrows. What are they? These are our three alternatives. What are they? The first one is construct large plant. The second one, construct small plant. Third one, do nothing. So, these are my decision alternatives. Now, for each of the decision alternative, there are two states of nature. So, as I said that the states of nature will be shown by circles. For each of them, there are two states of nature, and these states of natures are, one is favorable market, unfavorable market. Now, after this we have to write the payoffs. So, what are the payoffs? As we can see that the payoff for the large plant, and if we have a favorable market, then the payoff is 200,000, and if it is unfavorable, then the payoff is minus 180,000, and for a small plant these are 100,000 and minus 20,000. But if it is do nothing, then the payoffs are 0. Now, each of these also has some, these states of nature has a probability. We write those probabilities here. So, all these probabilities we know are 0.5 and 0.5. Now, if you recall, in our first or second class, we had dealt with the types of decision maker. So, again here it definitely depends on what is the type of the decision maker. Now, if the decision maker is, let us say, rational, then we can expect that he will be an expected value operator. Obviously, if he is pessimist, he would take the he will ignore the probabilities and would like to believe that worst state of nature is going to happen. But anyhow, we are assuming that the decision maker is what is known as rational. So, decision maker is rational. So, when decision maker is rational, then we can calculate what is known as the expected values for each of the situations. So, what will be the expected value if we construct a large plant? First of all, you look, the probabilities are 0.5 and 0.5 for favorable and unfavorable market, and these are the payoffs. So, what would be the expected value? Expected value for the first case is, let us say, case 1, that is for the large plant. The large plant expected value would be 200,000 multiplied by 0.5 plus minus 180,000 multiplied by 0.5. So, this will be 100,000 minus 90,000 equal to 10,000, right. So, these 10,000 we actually write here, right. So, this 10,000 is the payoff at this state of nature, and similarly for the second decision, that is construct a small plant, we are seeing that again it is 100,000 and minus 20,000. So, it will be 50,000 minus 10,000, the expected payoff would be 40,000, right. So, this is the second one, and what would be here, because both are zeros. So, obviously, the expected payoff will be 0. So, if we really now evaluate the expected payoffs at large plant, it is 10,000, small plant 40,000, do nothing 0. Therefore, the highest payoff in this case is the 40,000. So, we expect that kind of payoff to obtain, that is 40,000, which we write at the decision point, and therefore, the other payoffs we cross out. So, by looking at this diagram, it is very clear that it is as advisable to construct a small plant, because that is giving us the higher payoff. So, once again we let us look at what is there in the decision tree. We have a decision point, right, and the other we have the states of nature, right. So, here we have the states of nature, where we have decision point. Now, this is a simple problem, there is a single decision point. In a more complex problem, we may have a number of decision points. So, let us look at how all of these look. Just look at this example problem once again. This is exactly what we have done. There is a decision point, the decision node, and the state of nature node, and the three decisions are shown, and those are the states of nature. At the next level, we have shown the probabilities, that is 0.5 and 0.5, and we have also shown the payoffs, that is 200,000, then minus 180,000, 100,000, minus 20,000, and these are the two, they are the states of nature, and this is where the decision point. At the next stage, we are computing what is known as the expected values. So, already we have computed. So, again this is a revision. The expected value at node 1 10,000, expected value at node 2 40,000, and here because both are zeros, then this node is eliminated, but we can also keep if we like I have shown in the example. Now, at the last stage, you see these two are not there, right. So, finally, therefore, here we can write 40,000, and this is going to be our decision. So, this is how our decision tree problems are handled, particularly in the simple case. Now, here suppose look at this problem once again, the decision tree and the payoff matrix. So, this is a payoff matrix we have considered earlier. Now, suppose it is a question that how do we convert this payoff matrix to a decision tree. If you again recall, there are three decisions: redesign on a small scale, rebuild and refurbish, and do nothing, and those are our payoffs. So, suppose we have to convert this particular decision tree payoff matrix to a decision tree, then how do we go about? Let us look at this problem also. So, again the first question that comes to our mind, that what are our decision point or decision node. How many decision nodes should be there? Basically, since there are three decision alternatives, there will be a single one, because there is no secondary decision alternative, and there are three states of nature: favorable market change, unfavorable market change, and no market change. So, again we put a decision point or decision node, and here we have the three decision alternatives, right. So, three decision alternatives. So, what are those three decision alternatives? Let us write them down. First one is redesign on a small scale, right. The second one, rebuild and refurbish. So, let us call it rebuild, and the third one is do nothing. right. So, these are our 3 decisions, and for each of these decisions there are 3 decision points, 3 states of nature, not decision points. So, there are 3 states of nature. So, we can put them here. Right, and these are, first of all, no market changes, no change, then there are favorable market changes and unfavorable market changes. Same thing for all the options. Right, and the payoffs also should be put. The payoffs for the first one 30, 100 and minus 80. The payoffs for the second one 50, 200 and minus 200, and the third one is minus 80. No, sorry. The first one, redesign on a small scale, 30, 100, minus 80, 50, 200, minus 200, and this one is not minus 80, this one is 0, 30 and minus 50, right. Let us check once again the redesign option. The payoffs are 30, 100 and minus 80. The rebuild option 50, 200 and minus 200, and do nothing 0, 30 and minus 50. Now, we also need some probabilities. That probability, let us assume some probabilities here, and let us say that these probabilities are 0.5, 0.4 and 0.1, right. So, these are the probabilities 0.5, 0.4 and 0.1. Right. Now, what we need to do? We need to calculate the expected values for each of the cases. The first case, that is redesign the expected value EV would be 30 into 0.5 plus 100 into 0.4 plus minus 80 into 0.1 equal to 15 plus 40 minus 8. So, 55 minus 8 equal to 47, right. So, we write 47 as the expected value here, right. 15 plus 40, 55 minus 8, 47. So, what is the expected value for rebuild? For the rebuild option, the EV would be 50 into 0.5, 200 into 0.4 plus minus 200 into 0.1, again 25 plus 80 minus 20, this will become 85. So, we put 85 here, and in case of do nothing option, EV will be 0 into 0.5, 30 into 0.4 plus minus 50 into 0.1 equal to 0 plus 12 minus 5 equal to 7. So, 7 would be the payoff for do nothing. Now, let us look what we have done. We have computed for each decision option the payoffs in terms of the expected value. So, the expected values are 47, 85 and 7. So, since 85 is the highest, it is expected that one would go for the rebuild option and the other two options, that is redesign and do nothing, will not be taken. So, those options we are removing by crossing, and by looking at this decision tree, one can understand that the people would be preferring what is known as the rebuild option, because it is giving the maximum payoff. An interesting question that comes, supposing the person is a Maximax operator, what would be his decision from this particular decision tree? See, very interestingly, what a Maximax operator would do, the Maximax operator is an optimist. So, the optimist, he would not believe these probabilities. What are these probabilities? The 0.5, 0.4 and 0.1. So, he would like to think that if redesign option is chosen as a decision, the best state of nature would come. Which one is the best state of nature? That means where we are getting a payoff of 100. So, in this case, the optimist's payoff, I am writing in green, would be what is known as 100. What would the optimist would choose for the second decision option? It is the rebuild. So, you can see again the best state of nature, the best payoff is obtained under favorable, which is 200. So, obviously, here the payoff would be 200. And the third option where do nothing, again the payoff would be 30, because that is the best state of nature. So, the payoffs for the three decisions would be 100, 200 and 30. So, since 200 is the best option, in this case the payoff would be 200 and we cross out the other two here, and again the rebuild would be the choice. So, these are interesting to note that depending on the type of decision making, these calculations are going to be different and the person may choose different kind of payoff. So, this is about the decision tree for simple problems, but what will happen, suppose we have a slightly more complicated problem. Let us look at this example problem 2. So, if you look at this particular problem, again we find out that this is the problem that we have already done, that there are three alternatives: construct a large plant, a small plant and do nothing, and those are the payoffs. But suppose there is an additional option. What are those additional options? Consider that the company now can conduct a market survey. Based on the result of the market survey, the company can then make a decision on plant construction. Suppose we have to convert this to a problem of a decision tree, I mean through a decision tree construction, and what would be the payoffs. So, in this particular situation there are something more to think over, and what is that something more that we have to think of? Not only we have to look at the payoffs that are going to happen under the a priori situation, that is the probabilities are which are 0.5 each, but we have to understand that when we conduct a market survey, the market survey would give us some results, and based on those results the probabilities could be modified. So, first of all, even look at the decisions. What would be our decisions? The first decision would be that whether to do the market survey or not. So, let us try to think of that what are the things that are basically coming into the picture. So, this is the problem that we have taken up earlier. Our original decision was construct a small plant. The construct a small plant with expected value we had got is 40,000 in this particular case for a small plant, because that is what we have got. 0.5 into 100 was 50,000 minus 10,000 and 0 that was 40,000. So, the question is that anyhow we are constructing a small plant, but large plant, if market is coming out to be favorable, we can get as high as 200,000. So, we have definitely missed out there. We are happy with only 40,000 and which can go maximum 100,000 if the market is favorable, but it can lead to loss also. But the question is that suppose the market is favorable and we construct a large plant, we can get as high as 200,000. So, should we take a chance? So, why leave it before even considering that? So, those are that is the option before us. So, therefore, you see that the decision points, then there are two decision points to really consider. What are those two decision points? The first one is number 1, should we conduct a market survey? That is the question, right. So, should we conduct a market survey? Now, if we conduct a market survey, then two types of answers can come. The market survey, so let us put it here that we do a market survey. The market survey can tell that whether it is a favorable market or whether it is an unfavorable market. Please remember that the market survey may call it favorable, but we may not be able to 100% depend on it. That is another issue. So, if the market survey prediction is favorable, then again the second decision point is what should be our decision. In another language, which decision alternative would be chosen. Right. So, basically the problem becomes like this. First of all, whether to conduct the market survey. Now, the market survey results may come out to be favorable or unfavorable. If it comes favorable, then which decision alternative would be chosen, and if it comes out unfavorable, which decision alternative would be chosen, right. So, the problem is more complex and requires certain other conceptual understanding such as the Bayesian analysis, which we have discussed earlier. So, we stop here for this class, and in our next class we shall take it up. So, thank you very much.